Hi there. If xy over y minus 1 is equal to 3 and x squared y squared over y squared minus 1 is equal to 5, find x cubed y cubed all over y cubed minus 1. Express your answer in the form a cubed over b cubed minus c cubed, where a, b, and c are positive coprime integers. So before we start, feel free to pause the video so that you can work on this one first on your own. Okay, good. So let's start. So to solve this problem, what we can first do is we can try to use what we are given. So these two. So we'll have this one, xy over y minus 1 equals 3, and x squared y squared over y squared minus 1 equals 5. In here, take note that this first one can be written as xy equals 3 times y minus 1 by simply multiplying y minus 1 both sides. Take note that we can do that since y minus 1 out here cannot be equal to 0. Since if it is equal to 0, then this denominator will be equal to 0, so this whole would be undefined, and we know that to be not true. Then for this next one, we do the same, so we'll have x squared y squared equals 5 times y squared minus 1. Now take note here that this one out here, this one is actually equal to x times y, quantity xy squared. So what this happened because of loss of exponents. So given this, take note that we can plug in this equation out here into this one. So we can combine these two equations. So we'll obtain this. So this one out here is just the xy part. Since we know that xy squared is equal to 5 times y squared minus 1. And what we have here is just a polynomial equation. To be exact, it's a quadratic equation when simplified. So we can easily solve y out here. So we start by distributing the square and as well as the 5 out here. So we'll get 9. So 9 came from 3 squared. So 9 times y minus 1 squared equals 5y squared minus 5. Then expanding this one out here, we get 9 times y squared minus 2y plus 1 equals 5y squared minus 5. Distributing the 9, and we obtain 9y squared minus 18y plus 9 equals 5y squared minus 5. Now in here, what we do next is we subtract 5y squared both sides and we add 5 both sides to clear out this right side of the equation. So we'll get 4y squared minus 18y plus 14 equals 0. Observe that there's a common factor of 2 in every term in here, since 4 can be written as 2 times 2, 18 can be written as 9 times 2, and 14 can be written as 7 times 2. So dividing 2 both sides, and we get 2y squared minus 9y plus 7 equals 0. So this is what we have so far. So let's clear out some space. There. Next thing to do is we try to factor this one out to obtain the value of y. Now, in factoring this one, observe that it is not quite easy to see how to factor this. But take note that we can use the slide and divide method. So if you don't know that one, I can link a video explaining how the slide and divide method works in factoring quadratic equation. So continuing, if you haven't seen the video yet, I'll try to explain it briefly in solving this one. So we start with the slide. So what we do when we apply the slide in the slide and divide method is we move the coefficient of the leading term to the last term or the constant, and we multiply them. So we'll have here 2 times 7, and that will give us y squared minus 9y plus 14 equals 0. This one out here is now easier to factor out. So you can verify that the correct factoring for this one is y minus 7 rather. Y minus 7 times y minus 2 equals 0. Now that we were able to factor this, the next step is to divide. So when we divide, what we do is we divide the coefficient that we slided out here. So we'll have this, so we divide 2 both sides, and we will obtain y minus 7 over 2 times y minus 1 equals 0. This out here now is the factored form of the given. So now we can easily obtain the value of y. So from this, we know that either y is equal to 7 over 2, or this should be or. So just correct that one. So either y equals 7 over 2 or y equals 1. But take note that we can't have y equals 1, since if y is equal to 1, then this equation out here, xy over y minus 1 equals 3. So if we plug in 1, we'll have x over 1 minus 1 in the denominator, so that is 0 equals 3. And we know that this isn't true since x over 0 is undefined. So we can't have y equals 1. And so the only value for y in this case is y equals 7 over 2. So we now have a value for y. Okay, good. So the next thing to do is we use this value to obtain x. So we can plug it into either this or this equation. Let's plug it into this first equation. So we'll have xy over y minus 1 equals 3 to be x times 7 over 2 over all over 7 over 2 minus 1. So we just plugged in y out. To simplify things, we can multiply 2 over 2 out here to remove these denominators out here. And so we'll get 7x over 7 minus 2 equals 3. Simplifying the denominator, we'll get 7x over 5 equals 3. Now to obtain x, we multiply 5 over 7 both sides, and so we'll have x equals 15 over 7. So we now have a value for x. So far, we already have the value for x and y. The last thing to do is plug in these values into the expression that we need to find. So let's first clear out some space and move this around here. So let's now try to plug in x and y to this given expression. So we'll have x cubed y cubed over y cubed minus 1. This is equal to 15 over 7 cubed times 7 over 2 cubed all over 7 over 2 cubed minus 1. So we just plugged in x and y. Then we distribute the cube out here. So we distribute that in the numerator and in the denominator. So we'll get 15 cubed over 7 cubed. So this is times 7 cubed over 2 cubed all over 7 cubed over 2 cubed minus 1. Observe here that we can divide the 7 cubes out here. So we'll be left with 15 cubed over 2 cubed in the numerator, and in the denominator we have 7 cubed over 2 cubed minus 1. Now we are close to getting our final answer. Take note that we can multiply 2 cubed out here to remove this denominator out here, and so we'll obtain, so we're multiplying that in the numerator, this cancels out, and we distribute this to both of these, so we'll get 15 cubed over 7 cubed minus 2 cubed. Now observe here that this form is close to this one out here. The only thing we need to check is that if 15, 7, and 2 are positive coprime integers. Clearly, these 3 are positive. Moreover, these 3 are coprime since 2 is prime. Since 2 is just equal to 2 times 1, 7 is equal to 7 times 1, and 15 is equal to 3 times 5 times 1. So as you can see, their common factors is only 1. And when that happens, we say that these integers are coprime. So indeed, this form out here is what we are finding. So we conclude that our final answer is 15 cubed over 7 cubed minus 2. And so that is how we obtain the answer for this problem. So did you got that one correctly? Well, I hope you did. And yeah, I hope you enjoyed and learned a lot from this one, since I had fun in answering this problem out here. So yeah, that's it, and that's all for this how to solve video.